Good day, everyone. Today we shall be looking at the topic stoichiometry of a reaction. And in this topic, you are going to recall some essential concepts in chemistry, such as calculation of molar mass of a particular compound, and how to write formula of a compound should be extensively revised because we are going to make use of it in this particular topic, and balancing of equations. Okay, because this is a topic, the calculation whereby equation will be required. You'll be required to write an equation to balance an equation from which questions and calculation will now be given. Now, and we are having three basic things that you need to know. Three different basic calculations. The first one is mass mole calculation, whereby you'll be given mass and you'll be required to find a mole, or vice versa, or given a mole and you'll be required to calculate for mass. The second one is mass calculation. You'll be given a mass and you will also be required to calculate another mass. That is mass calculation. And the last one, which is the third one, is mass volume calculation. You may be given mass and you're required to calculate volume in the at STP, molar volume, or you be given volume and you're required to calculate mass. So vice versa, depending on how the question comes in. So these are already been fully explained, extensively explained as we move on.
So let us now look at the relationship between quantities. So I want you to recall that the formula to calculate number of moles, what is known as amount, is equal to reactive mass over molar mass. Symbolically, N, which is number of moles, is equal to mass over molar mass. Second one is molar volume. Molar volume is equal to reacting volume over 22.4 dm³. And Vn is equal to V over 22.4 dm³. Amount is equal to number of particles over Avogadro's constant, which is N over what? 6.02 times 10 to the power 23. These are the quantities and the formula that you need to put at the back of your mind throughout this topic. And also, you need to revise the calculation of molar mass, how you can calculate molar mass of a compound. Okay, so now let us now look at the relationship between quantities. In any given reaction, amount, molar mass, molar volume, or Avogadro constant can be calculated using the following formula. So, in any particular reaction, you can calculate any of the following. Either amount, which is the same thing as the number of moles, or molar mass. You can also calculate molar volume. You can also calculate Avogadro constant from a particular reaction. So let us look at the general formula that covers everything. Once you put this formula at the back of your mind, you are good to go. So let us look at the formula. It said 1 mole of any substance. This is standard formula. 1 mole of any substance, provided it is 1 mole. 1 mole of any substance will be equal to molar mass of that substance, which is also be equal to molar volume of that substance and equal to Avogadro's constant. So, symbolically, 1 mole is equal to molar mass, which is equal to molar volume 22.4 dm³, and Avogadro constant, which is equal to 6.02 times 10 raised to the power 23. Now, if you have 2 moles of a substance, that means 2 moles of that substance is equal to 2 times molar mass, which is equal to 2 times 22.4 dm³, which is equal to 2 times 6.02 times 10 to the power 23. Depending on the number of moles that you are having, will determine the coefficient that will use you to multiply the other quantities. So, but this particular equation or particular formula related almost 4 quantities. But in any particular reaction, 2 of this quantity will be required. So, but only one relationship will be required at a particular period. If you are given a question, you can only ask calculate probably molar, you can relate mole to mass, mass to mole, mole to volume, or mass to volume. So you cannot be asked more than two quantities in any given reaction. So let's say example here. So consider the reaction below. This reaction shows that hydrogen gas combined with oxygen gas to give steam. Okay, so if you look at the reaction, the coefficient before hydrogen gas is 2. That shows that 2 moles of hydrogen will require 1 mole of oxygen. 1 mole of oxygen. Okay, 1 mole before oxygen it is 1, not 2. 1 mole of oxygen, which is equal to 2 moles of water. 2 moles of water. So from there, if I calculate the molar mass of hydrogen gas, that is 2 times 2, which is 4. So 2 times 2 times 1, which is 4. So 4 grams. And oxygen is 2 times 16. Okay, 2 times 16 of oxygen will give us 32 grams. The molar mass of an atom is constant. For oxygen it is 1. For hydrogen it is 1. For oxygen it is 16. Okay, so that's why you're having 4. 4 before the bracket means 2 times 2 bracket 1. That 1 is for molar mass of hydrogen. So that gives us 4 grams. And for oxygen, O2. So the molar mass of oxygen, okay, mass number of oxygen is 16. So that 2 multiply the 16 to give us 32 grams. That is for oxygen. And for water, 4 for hydrogen plus 2 times 16, that gives us 36 grams. So I've been able to express them in terms of the molar mass of each of the atoms or molecules. So in terms of Avogadro's law, I'll be having 2 times the coefficient before hydrogen is 2. So 2 times 22.4 GMK. That is for hydrogen gas. For oxygen gas, the coefficient is 1. And in chemistry, 1 is not always indicated. So 1 times 22.4 GMK. And for water, the coefficient before water is 2. And that is why we're having 2 times 22.4 GMK. So this shows how we can relate mole, molar mass, and molar volume in a given reaction. So let's look at mass-mole relationship. Now, this is a calculation involving mole and mass only. Now, this calculation will be given mole and you require to calculate mass, or vice versa, or given mass and you require to calculate the number of mole. So, depending on the question. There's an example for this particular mass and mole relationship. Calculate the number of moles of calcium chloride that can be obtained from 25 grams of calcium triiodocarbonate 4 in the presence of excess hydrogen chloride. And you will be given the molar mass number of each of the atoms. For calcium 40, carbon 12, chlorine 35.5, oxygen 16, hydrogen 1. This is constant. We are going to supply with this molar mass number. So let's see the solution. Now, this question will test your knowledge on how to write a compound. How to write formula of a compound from its name. So we are told that calcium carbonate CaCO3 reacting with hydrochloric acid to give calcium chloride plus water, and CO2 is also produced. Now you need to write the equation on your own and you balance the equation. So this equation has been balanced. So now let us express it in terms of mole. And if you look at the question, we are being specific about number of mole of calcium chloride. So we'll be dealing with calcium chloride only and calcium triiodocarbonate 4 in this question. The other compounds, they are not really useful after we have balanced the equation. But in calculation, we are required to put in place calcium carbonate and calcium chloride. That is what we are interested in this particular question based on the question given. So if I have to express the two of them in terms of mole, 1 mole, you look at the reaction. Before calcium carbonate, you have there's no number there. That shows it is 1. So 1 mole of calcium carbonate will give us 1 mole of calcium chloride. So now I'm going to because the reaction said 25 grams of calcium triazocarbonate 4. That means we have to convert the calcium triazocarbonate 4 to molar mass. So now I'm not going to convert it. Calcium is 40, carbon is 12 plus O3. That means 3 bracket 16 for oxygen. So from there, I calculate everything. If I add everything and calculate, I'll be having 100 grams of calcium carbonate. So 100 grams, that's the molar mass of calcium carbonate. So 100 grams of calcium carbonate will require 1 mole of calcium chloride. Okay, because we have to calculate number of moles of calcium. So you will not convert calcium chloride to molar mass. We'll leave it in terms of mole. So 100 grams of calcium carbonate will give us 1 mole of calcium chloride. We'll now go back to the question. The question said 25 grams of calcium carbonate 4. That means that 25 grams of calcium carbonate will produce X mole of calcium chloride. So make X in terms of the formula. The number of mole of calcium chloride will now be 0.25 mole from this particular. So you have there is a relationship between mole and mass in this question. You are given mass and you have to find mole. So that's the meaning of mass mole relationship. So let's look at another aspect. This is mass calculation. You'll be given mass and you'll be required to calculate mass. In the previous one, you are given mole and we are given mass and we are asked to calculate mole. But in this case, it is mass calculation. You'll be given mass and you'll be required to calculate mass. So let's an example of this. Calculate the mass of calcium oxide formed when 1.5 grams of calcium is completely burnt in oxygen, and you are given the mass number of the atom required. So solution to this question, I've told you the first thing you are going to do is to write the equation of the reaction. So calcium reacting with oxygen gas will give us calcium oxide, and you balance the equation accordingly. This particular equation has been balanced by adding 2 before calcium and adding 2 before calcium oxide. So you look at this question very well. You have to calculate mass of calcium oxide. So in this question, I require calcium oxide and calcium. So I don't have anything to do with oxygen there. So I require calcium and calcium oxide. Now, if I express them in terms of mole first, so 2 moles of calcium, you look at before calcium, you're having 2. So that shows that 2 moles of calcium will produce 2 moles of calcium oxide. So because I'm calculating mass to mass, the question said mass of calcium oxide formed, and you are given 1.5 grams of calcium. So I'm going to express the mole in terms of molar mass. So I'll convert 2 moles of calcium and 2 moles of calcium oxide to their molar mass. So 2 molar mass number of calcium is 40. So 2 times 40 is 80 grams. For calcium oxide, 42, because that 2 will affect both calcium and oxygen at the product side. So 2 open bracket 40 plus 16. When you multiply, you'll be having 112 grams. So 80 grams of calcium will react with oxygen to produce 112 grams of calcium oxide. So we now go back to the question. The question is, we are given 1.5 grams of calcium. So what is the mass that will be produced by 1.5 grams of calcium? So 1.5 grams of calcium will give us X. We'll make X the formula, cross multiply and divide. You have X is equal to 2.1 grams of calcium oxide. So this particular question has demonstrated that you can be given mass and you will also be required to calculate mass. And it is termed mass calculation. Now, Having understood that, now look at mass volume calculation. The first one we look at is mass mole calculation. The next one is mass calculation. This one is mass volume calculation, whereby you may be given mass and you will require to calculate for volume, or you be given volume and you will require to calculate for mass, vice versa. Any one can be asked. So let us look at the example here. From the equation below, in this question we are fortunate because equation was given to us. So from the equation below, what is the volume of oxygen produced at STP, standard temperature and pressure, when 8.5 grams of sodium nitrate is heated until no further gas evolved? And we are given the mass number of the atoms concerned. Now, if you look at this question very well, we are only interested in sodium nitrate and oxygen. Okay, we are not interested in sodium diazonitrate that is there. We are only interested in the sodium diazonitrate 5 and oxygen that is produced. So we concentrate on the two. Okay, from the equation, we write the equation again. We are given that 2 moles before sodium nitrate. We have 2 moles to give us 1 mole of oxygen from the balanced equation. So I then convert sodium nitrate because I was given 8.5 grams of sodium nitrate in the question. That shows that I'm going to convert the sodium nitrate, the number of moles of sodium nitrate to the molar mass. So that shows that 2, I'll calculate the molar mass of sodium nitrate with respect to the coefficient, the 2 that was the coefficient. So 2 bracket 23 is the mass number of sodium plus 14 mass number of nitrogen plus 3 times 16. Okay, now when I add everything, I'll have 170 grams. But for oxygen, I was told from the question what volume. That's why I'm going to convert the number of mole of oxygen to volume. So 1 mole of this now gives us 1 times 22.4 dm³. So I've converted the mole to volume by multiplying 1, because the 1 there shows that the coefficient of oxygen is 1. If it is 2, I'm going to multiply with 2. But in this case, it is 1. So 1 times 22.4 dm³. And at the end, I'll be having 170 grams is equivalent to 22.4 dm³. I then go back to the question. I was given when 8.5 grams of sodium triazonitrate 5. So 8.5 grams will now give us X dm³. What is the volume that will be produced? Make X the order of the formula by multiplying 8.5 times 22.4 divided by 170, and we are going to get the final answer to be X is equal to 1.12 dm³ of oxygen to be produced in this particular question. Now that shows how we can relate mass to mole, mass to mass, and mass to volume.